So lesson number 30, our very last one for the semester, is on law of sines and law of cosines. Now, luckily, we learned this in Algebra 2, so as soon as I do some of these problems, you'll be like, oh, I remember all of this. All right, so here we go. The law of sines formula. Does anybody remember what it is?
Sine of A.
Yeah, sine of angle A over little a. Which could also be sine of C. So you can take any two of those ratios, right, and put them into a proportion, add them, or set them equal to each other, okay? So when I do capital A, capital B, capital C, I'm talking about angles. When I do little a, little b, little c, those are the sides that are across from those specific angles, right? Now, you might also see it written another way. It would be written as A over sine of angle A equals B over sine of angle B. It doesn't matter which way you're writing, right? Just as long as you're consistent as you're writing your proportion. All right, so the law of sines is used whenever we have angle, angle, side, or we have side, side, angle. Basically, what I do is I look to see if I can do SOHCAHTOA. How can I determine if I can do SOHCAHTOA or not?
Right angle.
If it's a right angle. If it's not a right angle, I look for law of sines. And if I can't do law of sines, that's when I do law of cosines. Does that make sense? You go through that like thought process. Okay, so we sketch it out. We're like, okay, angle A, that's an obtuse angle. It's 110 degrees. And then angle B is going to be 23 degrees. And then little a is 45. So little a is the side that is across from angle A. So it says find the other angle measures and side lengths. So if you remember, I was very particular about this in Algebra 2. I always had you guys write 6 things because it seems like people always forget at least one of them. So as long as you're writing that, you're going to be good. So we have angle A and we have angle B. Can we get angle C? Yeah, if I add those together, I get 133. So if I subtract from 180, what do I get? 47. Okay, so we're good. So this is going to be 47 there. All right, and then we have little a is 45. So we really only have to find 2 things, B and C. So what I would always do is I would use the original thing. So 47 we found. So don't use 47 because what if you made a mistake and did the classic mistake of subtracting from 200 instead of 180? I can't tell you how many people do that. Okay, so maybe you had 67 there on accident. So we don't want to use that number. So instead, what I'm going to do is I'm going to do sine of 110 over 45 equals sine of 23 all over little b. We don't know what b is. And we cross multiply. So you guys remember b times sine of 110 equals sine of 23 times 45. So if I want to find b, I'm just going to take sine of 23 times 45, and I'm going to divide by sine of 110. And you can do most of this like on your calculator. You don't have to write out all these steps. And we make sure we're in degree mode because we keep switching back and forth. Anybody faster than me? Did you get it? 18.7. We'll do 1, 1. We'll do 3 decimals. So 18.711. Okay, so the last thing, if I want to find C, well, then that's when I'm going to have to use that 47, right? So I'm going to set it up. So I'm going to say sine of 110 all over 45 equals sine of 47 all over little c. And we do the cross multiplying thing. Can you guys kind of do it in your head? Do I need to write out all those steps? See if you can get it.
It's 35.023.
That is exactly right. Good job. All right, so that's our answer. Kyle did it.
No, wait, wait, no.
You pointed to Kyle. All right, good job. Now, if you remember, there is one strange thing about law of sines. Do you guys remember this? So law of sines has something that we call the ambiguous case. So if the very first thing that you're finding is an angle, now in this case, we didn't have to find any angles, right? We got all the angles without using law of sines at all. Do you guys see that? So this is not going to involve the ambiguous case. But if the first thing that we're finding is an angle, then you could have more than one answer. You could have 2 answers, you could have 1 answer, or you could have no solution. Okay? So it says show that there could be 2 triangles, ABC, with measurements A is equal to 45 degrees, little a is 5, and little c is 6. Okay, so we want to show that there are going to be 2 things. So basically, as we do this problem, we set it up and we're like, okay, I have sine of 45 degrees, and I have over 5 equals sine of angle C, which I don't know, over 6. So we multiply that 6 over. 5 looks like a 6. So I take my sine of 45, divided by 5, and then I multiply the 6 over. So I get 0.8485 something equals sine of C. Okay, so here's the weird thing. All right, you guys have enough pre-calc knowledge. You did not in Algebra 2. You probably didn't understand why this was true at all. Think about your unit circle. On your unit circle, there are 2 places where the sine is equal to 0.8485, right? They're going to be up really, really high up. They're going to be really close to 1. Does that make sense? So if I do inverse sine and I find the first one, so inverse sine of that answer, I get C is equal to 58.052. So that's going to be that angle there, 58.0. I drew it really close. It's not really that close to 90 degrees, but it's there. So how do I get this other angle measurement? Subtract it from what? From 180. Does that make sense? Yeah, you're saying pi, but we're not in radian mode, right? We're in degree mode. Okay, so we're subtracting from 180. That's why we have a second value for C. So we could also have 180 minus 58.052, which is going to be 121.948. That's our second answer for C. Does that make sense? So we could have 2 different angles for C. We could have an acute angle, or we could have an obtuse angle. Okay, and I tried to illustrate that in this picture. It's always hard to draw. But basically, you know, if we have A, and we have C here, and we have B here, here's one triangle that works with those measurements. Okay? So C would be an obtuse angle in that case. But if I take this side, and it's on a hinge, and I hinge it over to here, right? All those other measurements are the same. I still have 5, I still have 6, I still have 45. Does that make sense? But now C is going to be an acute angle. That's what's happening. So basically this will happen when you have a small angle to begin with, and the side across from it smaller than the side that's next to the angle. Okay, because then that side can kind of hinge over. Okay, but basically as you're solving, what I always said last year is whenever you're solving for an angle first, always do 180 minus to see if it also works. So what if I had gotten something too big? Like when I subtracted from 180, let's say I got 140 degrees. That won't work. Why won't it work? Because our original angle was 45. Does that make sense? 45 plus 140 would be too big. Do you guys see what I'm saying? Then you would only have one answer. Okay. So with this, with the ambiguous case, you could also have no solution. So as you're solving this one, so we have A, B, and C, and we have C is 54, and little c is 5. And B is going to be 8. So as you solve this one out, you have sine of 54 all over 5 equals sine of angle B all over 8. And you multiply that, so you do the sine of 54 divided by 5, and then times that 8, multiply it over. So you get sine of B is equal to 1.2944. So when you try to do inverse sine, that doesn't work. Okay, because you can't have sine bigger than 1. Okay, so this one's no solution. All right, does that make sense? Does it make more sense than it did last year? Like when you were in Algebra 2, you're like, why do I do this 180 minus? It's because of our little unit circle thing. Okay, so I think now that you've had more trig background, it makes more sense. All right, so number 3, so solve the triangle ABC when A is equal to 5.9, B is 7, and A is 27. So I'm going to set it up. I'm going to have sine of 27 all over 5.9, so sine of capital A over little a equals sine of angle B over little b. So basically the first thing that I'm solving for is an angle. And remember, the ambiguous case always happened when we had the bad word ASS, right? We really call it SSA in every textbook. But yeah, so that's what we're kind of looking for. So do you guys see how these are all set up as angle, side, side? That's when we might have something weird, when we can have 2 answers, or just 1, or 0. All right, so as I do this, I have sine of 27. I'm dividing by 5.9. I'm multiplying the 7 over. So I get sine of V is equal to 0.5386 something. I keep that number in my calculator. Are you guys doing this along with me? And I get B is 32.591 degrees. That's the first answer that I've gotten. So since my first answer is an angle, I always have to do 180 minus. So I check for a possibility for B2. So 180 minus the 32.591 gives me 147.409. Can that 147 work with my original 27?
No.
I don't know. Let's try it. Let's do that number plus 27. When I add them together, do I have enough room left to make 180? I do.
Oh, yeah.
I get 174 something, right? So it works. So that's when we have two triangles. So we'll say first triangle, second triangle. It's annoying writing out the answers. I know. I make these keys as well. All right, so I'm going to have 27 and 27. Write down all the things that we had originally. B was 7, B was 7, A was 5.9, and 5.9. So we're good there. But B1 was 32.591. And B2 was 147.409. So that's the obtuse one. Okay, so we can find C. We're just going to add them together. So 32.591 plus 27. And then if I subtract that answer from 180, this one's going to be 120.409. And then the other one, 180 minus is 174.409. The other one's 5.591. Okay, so we at least have all the angles in the two triangles. So last thing we need to find is C then. So really, I mean, you have almost all the information. It's not really that terrible when you have two triangles. It's just a lot of information to write down. So we're going to do a sine of angle C for the first triangle. So 120 point whatever. So 0.409 divided by little c equals sine of angle A over little a, 5.9. Can you guys do that without writing all the steps? You're just letting me do all the work, aren't you? Try it with me. Just space them out. All right, what do we get for C for that one? You really are making me do all the work, aren't you? You're just waiting. All right, 11.208. Can you do the next one for me, please? So if I do the next one, it's the same setup, but now the C is different, right? So I'm going to have sine of 5.591 all over little c equals sine of 27 all over 5.9. It's very small, yep. What do you get? Exactly. Thank you, Natalie. All right, so those are all your answers. All right, so that's the weird thing about law of sines, right? All right, so you might have things that you have to draw. I know some of you guys don't like some of the story problems, but let's just sketch this one out. We won't solve it out, but we'll at least draw it, okay? So it says two surveyors standing at points A and B are measuring a building. The surveyor at point A is 20 feet further away from the building than the surveyor at point B. Okay, so here's our building, and B is here, and then A is 20 feet further away. The angle of elevation to the top of the building from point A is 58, and the angle of elevation from the top of the building to the top of the building from point B, that's not very straight, is 72. How tall is the building? Okay, and we've had this before. We've done problems like this before, right? But when we did them, we didn't use law of sines. So the best thing to do in this situation is use law of sines and find what I'm calling x right there. You guys see it? Because once you find that, you can use SOHCAHTOA on the other one. Does that make sense? So one step at a time. It's much, much easier than doing the thing where we did a system of equations. Okay, so using law of sines in this situation is much easier than SOHCAHTOA with the system of equations. So you would set it up and you'd say sine of 58 all over x equals, well, what do we need? We actually have to find an angle. We have to find this angle here. Can we do it? What about the 72 triangle? 72, 90, and what? 18, right? Okay, 18. And then we have 58, and we have, so like the big triangle, we have 58, and we have 90 degrees. Can we find that whole angle? Yeah, that would be 32. So, yeah, Louis is right. That little one would be 14 degrees. Do you guys get it? So we'd have sine, did I hear no? It's not that bad. Sine of 14 degrees. Do I need to go through it again, or do you really get it? It sounded like a sarcastic no. All right. All right, so we're good. And then you cross multiply and you find x. Let's just go through it. It doesn't take very long. So we get x is equal to 70.109. And then once you have that, we have another triangle, but we can just do SOHCAHTOA now. Because we have h and we have 70.109, which I'm going to keep in my calculator. So I'm going to have opposite over hypotenuse. So sine of 72 equals opposite over hypotenuse. So I take that sine of 72 and I multiply by my answer. So then we easily get that h is 66.678 feet. Okay, much easier than the system of equations though, right? So that's the trick on this one. We like that, right? Yay. All right. Area of triangles. We did not talk about this in Algebra 2. So these are new formulas. All right, I will give you these formulas if it's on your final or your practice test. So it says the area of any triangle is 1/2 the product of the lengths of the two sides times the sine of their included angle. Okay, so in other words, let's say I have the angle A. Then if I have an angle of A, then the sides next to it are B and C. Do you guys see that? So you're going to have 1/2 of the product of the lengths of the two sides, so let's say B and C first, times the sine of angle A. Or if I didn't have angle A, but instead I had angle B, then what two letters would I have next to it? A and C. See how it works? Oh, wait, not BC. I've already done that one. So what else do I need? Sine of C. So then AB. So it says why. During the proofs of the law of sines, the height of the triangle was h, which was b times sine of a. So that came from this little thing here. Like your angle, the sine of an angle is opposite over hypotenuse. It was h over b, sine of a. So therefore, the triangle is 1/2 base times height. So it's 1/2 c, that was the base, and then the height was that b times sine of a. So it worked out. Okay, so that's kind of where that's coming from. It's like using a right triangle to use the. I'm going to go back to that. All right, so that you can find the area of a triangle if you have its angle and the two sides next to it. Okay, so that's one way. But you can also find it if you have all three sides. We'll talk about both formulas. All right, so this one. So find the area of the triangle shown in the figure above. So we're going to say sine of 153, and we're going to multiply by 1/2 of 5 times 6. That looks like 5.6. I didn't write that well. So I'm going to have A equals 1/2, 5 times 6 times sine of 153. That's it. Easy formula, right? I shouldn't even give that to you. I should just make you do it. All right, so our area then is going to be 6.80, well, we'll say 810 square centimeters. This is an area. All right, so our other formula is when we have all three sides of a triangle. So if we have all three sides of the triangle, we use what we call Heron's formula. Okay? Yeah, I would definitely give it a try. It's not that hard to remember, but just in case you panic. So basically the S that we're finding is going to be almost the average of those numbers, but it's really just the three numbers added divided by 2, not divided by 3. It's kind of weird. And then you use that number 4 times in your formula. So it says find the area of the triangle whose sides have length of 8, 10, and 14. So the first thing we find is S. So we do 8 plus 10 plus 14, and we divide by 2. So what do we have? 18 plus 14, 32 divided by 2, 16. And then our area formula, we start out with that 16, the S. And then we do S minus each of the sides. So S minus 8. Well, I shouldn't say S, should I? 16 minus 8. 16 minus 10. 16 minus 14. So it's pretty easy. A lot of people will forget that S out front, though. So you have 16 times 8 times 6 times 2, which becomes 1536. So when you take the square root of that answer,
39.191.
192. Yep, good. And then it'd be whatever units you had, so square units. That's it. Good job. All right, and then the very last thing we have is the law of cosines. All right, so here we go. So law of cosine. So if you start out with it, let's say you start out with c squared. It starts out just like diagonal theorem. C squared equals a squared plus b squared. And then minus 2ab cosine of c. So it's kind of similar to that area formula, except it's 2 instead of 1/2. So do you guys remember that? Do we need to talk about that?
I remember 80 plus.
All right, so, and then the only thing that's weird about law of cosines is if you have side side side, you have to find the largest angle first. So if you have 8, 10, 14, like we just had, you have to do the 14 squared first before you begin. All right, so number 1, so it says find the angles of it, find the angles of triangle RST as shown below. You only have to do it one time. That's the good thing about law of cosine. If you do it once, then you can do law of sines from then. Okay, so what's the largest side? 90. So that means I'm going to start out my formula with 90 squared. So I'm going to have 90 squared equals 70 squared plus 40.5 squared minus 2 times 70 times 40.5 cosine of my angle. Now, since I was doing 90 first, it's the cosine of r. It's whatever was across from 90. And the biggest mistake people make here is they try to combine all of these numbers. So do you guys see how the cosine of r is attached to that number? So sometimes it helps if people do big parentheses there so they know those are all together. So what I like to do is I like to subtract the 70 squared and the 40.5 squared over so I don't get confused. And then I have negative 2 times 70 times 40.5. So negative 5,670 cosine r. So I do 90 squared minus 70 squared minus 40.5 squared. Oops, cosine r. And then I divide that over. So I'm going to divide by the negative 5670. And then do inverse cosine. So we end up getting r is equal to 105.967 degrees. Okay. So now if you want to find the next angle, we could just do law of sines, right? So I'm going to say sine of 105.967 degrees all over little r is 90 equals sine of s over 70. And I keep that number in my calculator. And I do some rearranging. So I get 0.74777 equals sine of s. So then s is going to be inverse sine of that answer. So it's going to be 48.398. Okay, last step. Do I need to do the law of sines again? No, just subtract from 180, right? I can't tell you how many times I've been grading tests, and I see that people do law of sines for every single one. And it takes a long time. That's a lot of work. Especially like the last one. It's like you have 2 angles already. Like, why did you do it one more time? So don't overthink it. All right, so surveyors use this to find distances. So here's an example. Like you have 2 houses, you have a lake across them. You can't just like run a, what do you call it? Like a measuring tape across the lake. Okay, so that's when you would use law of cosines. Does that make sense? So if you want to find this distance, we'll call it C. You're going to swim under the water and carrying your measuring tape? All right, so we have to do that. So we're starting out with C because that's the angle we have. So we're going to say C squared equals 50 squared plus 90 squared minus 2, 50 times 90, cosine of 50. And this is one that you could just put straight into your calculator because you don't have like cosine of A or cosine of R or whatever. So I get C squared equals 4,814.912. So when I take the square root, I get 390. And that's in feet. Okay. It's all coming back to you guys. Do you remember how to do this? Okay. So we do have 2 other examples, but I think we're probably good. I think you guys have seen enough. You guys remember it? Okay. All right.